So hopefully you guys are reading this class opener and understanding what to do. Like number one, they want you to graph it. We want to rewrite it in slope-intercept form. So what would we do to number one to get it in slope-intercept form? Divide by -2. And let me change that. Divide by -2. Divide by -2. Divide by -2. And we're going to end up with y equals -3x plus 2. So now it's in slope-intercept form. Now we know where it crosses the y-axis, where it crosses, and how much you rise and how much you run. So where does this cross the y-axis? Anybody?
0.
Crosses the y. What's the b value on this thing? 2. So it crosses right here. And from this point, what do? Do I go up or do I go down?
Yeah.
Down. Why is that? It's a -3, so you're going to go down 1, 2, 3, and you're going to go over 1, okay? So once again, the slope is -3 over 1, so you go down 3 over 1, and you have your line right there. So let's draw that line. Put some arrows on it, we're done. Number 2. This one's almost in slope-intercept form. All I have to do is what? Add 3 to both sides. So we're going to go plus 3 here, plus 3 over here, and we're done. It's in slope-intercept form. Y equals -2/3 x plus 3. So where does this one cross the y-axis? What's the b value of this one? +3. It's going to cross at 1, 2, 3. It's going to cross right here. And from that point, what do? Down 2 over 3. So we're going to go down 1, 2 over 1, 2, 3. And put the dot right there. And of course, draw our line. And ladies and gentlemen, we have graphed. Piece of cake. So, number 3. Check if 0, 0 is a solution to x plus y is less than or equal to +1. How do we check if an answer actually works? Plug it in, right? Just plug it in, see if it works. And remember, a coordinate is really a x value and a y value. So what we're really saying is x equals 0 and y equals 0. So let's see if these answers right here, the 0 for x and 0 for y, let's see if it actually works when we plug it in right here and right here. So if we plug them in, we're going to end up with 0 plus 0 is less than or equal to 1. Is that a true statement or false statement? True or false? True. Rocky, what do you think? True. Okay, so yes, this is a solution. 0, 0 is an answer to the inequality x plus y is less than or equal to 1. What do you guys think of number 4 right here? Check if 0, 0 is a solution to y is greater than -2/3 x. What do you guys say? Is it a solution? Yes? No? Stuart, what do you think? Stuart? So what I'm asking here, Stuart, check it out. If you look at the screen, this is my x value, and I plug it in right into this x. This is my y value, so I plug it in right into this y. So if I do plug in a 0 here and a 0 there, will this be a true statement or false statement? False. Because we have 0 is greater than -2/3 times 0. That's still going to be 0, right? That's going to be 0 right there. So 0, is it greater than 0? No, it's not. 0 is equal to 0. So this is a false statement. So you would say no, 0, 0 is not a solution to this inequality. Okay, I'm going to give you guys a couple of minutes, and I'll ask you guys right now on numbers 5 and 6. Go for it. Okay, so the first thing to do is to recognize what your x value is and what your y value is. X is 0. So what we're going to do is plug in 0. This 0, we're going to plug it in right into the x. The y is 5, so we're going to plug in the 5 right there into the y. Okay? So if I plug it in, I'll have a 5 is greater than or equal to. Now imagine that I actually took this 0 and plugged it in for x. That'd be a 0 right here. which means that negative 2/3 times 0 is still going to be 0. So if I have 0 plus 5, that's going to be a 5 on this side. Does that make sense? So is 5 greater than or equal to 5? Yes, it's true, because it is equal. 5 is equal to 5. Now, if it didn't have the or equal to, if it was just greater than, 5 is not greater than 5, but 5 is equal to. So this line makes it a true statement. So you would say, yes, it is a solution. Okay? Let's go for the last one. Y is 3, so you have 3. Well, that's an ugly 3, sorry. There you go. 3 is less than negative 3 halves times x, and x in this case is 2, and plus 6 at the very end. So I'm just plugging it in, replacing the y with the 3 and the x with the 2. And now I'm going to do some math. I'm going to simplify it so I could see if it's true or false. So when I look at the negative 3 halves times 2, whenever you multiply a fraction by its denominator, the fraction cancels out. So we really have 3 is less than negative 3 plus 6. So when you work out the negative 3 plus 6, that's 3. So you really have 3 is less than 3. What do you guys think? No, that doesn't work. So this is false. So you would say no, it is not a solution. Okay. So on this class opener, we practiced all the skills that we need for this particular section. Okay. Now, let's first learn how to graph inequalities before dealing with systems of inequalities. So here are the steps to graphing inequalities. Step 1 is to make sure that it's in slope-intercept form, y equals mx plus b. So if it doesn't have y by itself, if it's not in slope-intercept form, you have to rewrite it in slope-intercept form. Step 2 is to graph the line, but instead of just drawing a line, you have to decide if the line is solid or dotted based on the inequality. So if you do have an or equal to, whether it's greater than or equal to or less than or equal to, it will be a solid line. But if you just have a greater than, less than, without the or equal to, then it's not going to be a solid line. So it's this simple. If your inequality has a solid line underneath it, it's going to be a solid line. If your inequality does not have a solid line underneath it, it's not going to be a solid line. We're going to make it dotted or dashed, whatever you want to call it. And then we have to shade in by testing a point and seeing where all of our solutions are at. So if you just read through these steps, it's kind of confusing, but if you actually work through them, it's not that bad. So let me do an example for you up here. Step 1 is to graph it the way you did before. Make sure it's in y equals mx plus b. Is it in y equals mx plus b? Yes, it is. Okay, yes, it is. So we need to get it by, we need to graph it. What's the b value? 2. Let's put a dot at 2. And what do I do from that point? Do I go up or do I go down? Down. How many? Down 3. 1, 2, 3. And then over? Over 2. So I put a dot right here. And now I need to decide, step 2 on the ones we just read, is to decide whether this is going to be a solid line or where it's going to be a dotted line. Right? What do you guys think? Solid or dotted? Again, the instructions say if you have a solid line underneath your inequality, it's going to be a solid line. Do we have a solid line underneath here? No. So is this going to be a solid line? No, it's not. It's going to be dotted, right? So I'm just going to make this dotted or dashed, whatever you want to do, right? Can't be solid though. Okay, so our answers are either going to be on one side of this line or the other side of this line. So our answers are either going to be down here, all of them down here, or all of them up here. Okay? So how do we know if an answer is an answer? We did it on the class opener. You plug it in and you check, right? So what we need to do is select any point, all right? Go ahead, tell me when to stop. Stop. Okay, so let's say I stop right here, and that's the coordinate, negative 1, 2, 3, negative 3, 0. So what I could do is test this point, negative 3, 0, and see if it works, right? Now, what do I mean by test it? you have an x value as negative 3 and a y value of 0. So if you were to plug in your x value of negative 3 right here and your y value of 0 right there, and if it's a true statement, then it works. If it's not a true statement, it doesn't work. Now, we could plug in negative 3, 0, but which point do you think is the easiest to plug in? Anybody? Easiest point to plug in instead of negative 3, 0. 0, 0. Good call. So if we were to test 0, 0, 0, 0 is the easiest point to test. Why? Because when you plug in 0, anything times 0 is 0. As opposed to negative 3 times negative 3 halves, you end up with fractions and stuff. So let's test 0, 0. So we're going to plug in a 0 for y and a 0 for x times 0, and then plus 2 at the end. So we could clearly see that this statement is going to be 0 is less than 2. Let me ask you, is that a true statement or false statement? 0 is less than 2. True. Okay, so what does that tell you about this dot down here? That it is a solution. All right, now all the solutions are going to stick together. They're either all on this side or all on the other side. So obviously 0, 0 works. So all of our answers are down here. And this is where we do the shading, part 3. You either shade in one side or the other side. Now what does this shading mean? It means that any coordinate down here, any coordinate will work. The negative 3, 0 would have worked. Any coordinate down here would work. But the easiest point to use when you're testing to see where your solutions are at are 0, 0. So the only time you don't use 0, 0 is if your line actually crosses through 0, 0. Then obviously you want to pick another point. Let's go through a couple more examples here. Number 2, it's ready to graph. It crosses where? Where does it cross? Negative 2. Okay, so it crosses at negative 2. What do I do from that point? Up 4. 1, 2, 3, 4. Over? Over 1. Okay, let's put a dot right there. And is this going to be a solid line or a dotted line? This one is solid. Oh, that's crooked. Why is it solid? Because it has a solid line underneath the inequality. Okay, now we either need to shade in this side or this side over here, depending on where our answers are at. Okay, so you need to test a point. Okay, you can test any point you want, right? But the easiest point to test is 0, 0, right? So the only time you don't test 0, 0 is if this line actually crosses right through 0, 0. Because if it did cross right through 0, 0, then you wouldn't know which side of the line your answers are on, right? If it works, if it doesn't work, it doesn't really matter because it's on the line. So right here, 0, 0 is clearly on the left side. So it's okay to use 0, 0. If it works, I shade in this side. If it doesn't work, I would shade in the other side. So if we test 0 for x, 0 for y, it's going to say 4 times 0 minus 2. We're going to end up with 0 is greater than or equal to negative 2. True or false? 0 is greater than or equal to negative 2. True. 0 is greater than any negative number. So does this point work? Is it a solution? Yes, which means that all of the points on this side are the solution, or are solutions to the inequality. So you shade in this side. Does that make sense? Now, again, the shading means that your answers are all over here. None of these are answers. All of these are answers. All of them, right? Like if I were to pick the point, let me just go with this point right here. That's the coordinate negative 1, 2, 3, 1. So if I were to test negative 3, 1, I already know it's going to work. Now, how do I already know it's going to work? Because I already know that all my answers are on this side. So any point I pick will work. Any point from over here will not work. Let me demonstrate that. The negative 3, positive 1, if you were to plug it into your original inequality, it's going to be 1 is greater than or equal to 4 times negative 3. 4 times negative 3, and then minus 2 at the very end. Ugly 2, sorry. So anyways, if we were to work this out, you're going to have 1 is greater than or equal to negative 12 minus 2. 1 is greater than or equal to negative 14. That's absolutely a true statement. And that's obvious because all of our answers are over here. I just tested that one, it worked. If I test one over here, it's not going to work. Okay? So that's the whole point of shading, to show where all your answers are at.